The universe, along with the trillions of objects it contains, is a remarkably fascinating system. Every object, every atom, in short, everything within the universe possesses distinct characteristics and unique beauties. So, what is the largest object in this vast universe? Today, together with you, we will dive into the finest depths of this question. We will take a detailed look at the largest objects in the universe and explore what factors influence the size of an object in cosmos. Before jumping into our video, don't forget to hit the like button, subscribe to my channel to support me, and share your thoughts in the comments for new video ideas. Now, if you are ready, we can move on to our video. First of all, contrary to popular belief, how large an object is in the universe is not evaluated solely by its physical diameter. At the same time, that object's mass, the volume it occupies, and the amount of matter it contains are also taken into account. In fact, in certain scenarios, even the gravitational effect is considered. Because of this, when you ask the question, what is the largest thing in the universe, you cannot get a single answer, or rather, you cannot reduce it to a single answer. However, when we classify the largest structures scientifically, a hierarchical structure emerges. The largest structures in the observable universe are not individual objects, but rather galaxy clusters and the superstructures they form. In other words, you can only compare the sizes of objects like planets or stars among themselves. For instance, the largest of the stars or the largest planet in the solar system. Aside from that, the largest structure, object, or region of the universe, however you prefer to name it, is not a standalone object. That is to say, perhaps the largest star in the universe might look like a mere grain of sand next to the universe's largest structure. In this context, one of the largest structures observed today is a colossal entity called the Hercules Corona Borealis Great Wall. This massive structure is approximately 10 billion light years long. Truly an unbelievable length, isn't it? This means that to travel from one end of this structure to the other, you would need to travel at the speed of light for about 10 billion years. To better illustrate this length to you, I can make the following comparison. If you possessed a vehicle capable of reaching the speed of light, you could travel around the Earth in just 0.13 seconds. Furthermore, to convey the immense magnitude of this structure's length, I can also tell you this. The Andromeda Galaxy, which is the closest galaxy to us, is about 2.5 million light years away. So, while you can reach Andromeda from here in 2.5 million years at the speed of light, you can only go from one end of this structure to the other in 10 billion years. From these comparisons I have made, you can grasp just how long or massive this structure is. However, as I mentioned at the beginning, this structure is not a single object, but a region where galaxies are heavily concentrated. Within this region, there are galaxies, gases, and dark matter. Yet, in a general sense, we can call the structure a colossal network of galaxy clusters. When we look into the category of more individual objects, we see galaxy clusters and superclusters. Note that the previous structure we mentioned was a network of galaxy clusters. What we are talking about now is simply galaxy clusters and superclusters, so please do not perceive it as if I am talking about the exact same thing. To give an example, the Laniakea supercluster is a massive structure that also contains the Milky Way, and it is approximately 520 million light years in diameter. These types of structures consist of galaxy clusters bound together by gravitational effects, but these structures are also not technically a single solid object. They are large-scale structures bound together as if by a loose rope. Actually, before moving on to galaxies, I want to talk to you in detail about the Hercules Corona Borealis Great Wall, that is, the network of galaxy clusters, also known as cosmic webs, because these structures harbor very distinct pieces of information. Moreover, when you look at them, these structures clash a bit with our calculations, because the size of structures like Hercules Corona is far, far beyond the maximum expected size scale we have calculated. The formation of the cosmic web dates back to the earliest moments of the universe, and immediately after the Big Bang, the universe was not entirely homogeneous. There were tiny density fluctuations, and these fluctuations grew over time under the influence of gravity. While dense regions grew by pulling in more matter, sparser regions turned into voids. This process, spanning billions of years, ultimately brought forth the cosmic web structure we observe today. So, the foundation of the largest structures in the universe was actually already laid at the very moment the universe was born. At this point, perhaps the most critical concept of our video comes into play: scale invariance. That is, the distribution of structures in the universe shows similarities up to a certain scale. When you look at a smaller scale, galaxies cluster together, and then when you look at a larger scale, galaxy clusters begin to cluster as well. And on an even larger scale, the superclusters I mentioned at the beginning emerge. This situation naturally cannot continue forever, and past a certain point, the universe begins to appear homogeneous. This limit is around 300 million light years. Beyond Beyond this scale, every direction of the universe has, on average, a similar density. Right at this point, we have arrived at the part I mentioned that contradicts our calculations. The Hercules corona wall has exceeded this theoretically known maximum scale and is a structure far beyond it. This situation remains one of the most debated topics in cosmology today. While some scientists argue that this structure is one of the statistical anomalies in the universe, others suggest that the universe might not be as homogeneous as we think. So which side are you on? If you have written your answer, now I will tell you about the most striking features of the cosmic web, and then I will move on to galaxies. The strangest, most striking feature of the cosmic web is the empty spaces, meaning the voids. The regions referred to as voids consist of areas that are almost completely devoid of galaxies, and the sizes of these regions are by no means negligible. This is actually a bizarre paradox. In a structure formed by clustering galaxy clusters, there are regions of immense proportions containing absolutely no galaxies. One of the most famous and largest of these regions, called voids, is the Boötes void. This region was discovered in 1981, and when it was found, the scientific world was completely shocked, because scientists never expected to encounter such a massive nothingness in the universe. This void is approximately 330 million light-years in diameter and is truly of immense scale. This is exactly what I meant at the beginning when I told you that there are a myriad of different objects, structures, and systems in the universe. Even a nothingness can surprise us to an extreme degree. Among individual structures, one of the first examples we can point to as the largest entities is galaxies. Galaxies can sometimes be unpredictably small, while other times they can be unimaginable large. For example, our galaxy, the Milky Way, is the type of galaxy we can call medium to partially large, containing 100 to 200 billion stars. However, giant elliptical galaxies like IC 1101 are vastly larger than our galaxy and can harbor close to 100 trillion stars. The diameter of the IC 1101 galaxy is approximately 6 million light-years, and these values make it one of the largest known galaxies. However, there are also certain values that need to be measured in galaxies. That is, the size of a galaxy is not measured solely by the stars or planets it harbors. The dark matter halo of the galaxy is also very important at this point because a major part of galaxies is invisible, and these parts consist of dark matter. Looking at the colossal structures on a smaller scale after galaxies, stars come next. The largest stars found in the universe are called hypergiant stars. The star named UY Scuti is the finest example of these hypergiants because it is one of the stars with the largest known radius. To give an example, the radius of this star is approximately 1,700 times the radius of our star, the Sun. I mean, look at this massive difference. While even the Sun appears colossal to us, this star is 1,700 times the size of the Sun. If we were to somehow see this star side by side with the Sun, in all likelihood, the Sun would now appear as a very tiny star to us. And if this star were placed directly in the Sun's position, it would create a catastrophic environment for the solar system because its surface would extend beyond the orbit of Jupiter. This means Mercury, Venus, Earth, Mars, and Jupiter would be swallowed by this star, and a massive portion of the solar system would be obliterated. However, the truly critical thing here is the density of the star. The densities of such colossal stars are very low, meaning despite being extremely large, their interiors are quite sparse in structure. When we look at it in terms of mass, the largest stars are different. The most massive stars are generally around 100 to 300 solar masses, and these types of stars typically have a very short lifespan. Furthermore, these stars are destroyed by those famous supernova explosions, which shows us that the universe does not allow extremely large and extremely massive individual stars to exist for a long time. From this point on, it might sound intriguing, but black holes come after stars. Because when it comes to black holes, measurements get quite complicated. There are black holes that are small in size, but monumental in mass. Yet there are also black holes that are large in size, but small in mass. So, minds get a bit confused regarding classification here. However, we can state that even if black holes are not extreme in terms of physical size, they are the most extreme structures in the universe when looked at from the perspective of mass and density, because supermassive black holes can possess millions or even billions of solar masses, which I mentioned to you in my previous videos. If you haven't watched it, don't forget to watch, and like the two-part series where I conducted very detailed research on black holes. Anyway, to give an example of supermassive black holes, the mass of a black hole located at the center of the quasar named TON 618 is approximately 66 billion solar masses. Even though this sounds simple when spoken in words, this mass is truly a colossal mass. To reach that mass, 66 billion suns means an image that we, as humanity, can never truly visualize in our minds. Furthermore, the event horizon of this black hole is so immense that its diameter could easily swallow the entire solar system. Yes, you heard it right, the entire solar system. However, of course, there is an important distinction here. Although black holes appear physically large, all of their mass is actually concentrated into a single point, namely a singularity. If you were to ask what the most important factors influencing this size in the universe are, the answer to this is, of course, gravity first and foremost, because gravity allows matter to come together and small pieces form stars, while stars form galaxies. However, gravity also has a limit past a certain point, and on very large scales, the expansion of the universe begins to defeat and crush gravity. For this reason, a single structure of infinite size can never form in the universe. Another factor is the internal pressure and energy balance. To give an example, stars escape collapsing thanks to the nuclear fusion inside them. However, if this balance is disrupted, the star either collapses into itself or explodes. This actually shows us that size consists of a balance, and if this balance does not exist, no object can survive. Additionally, matter density also plays a critical role. Two different objects can be the same size, yet one can be far more dense than the other. The finest example of this topic is actually neutron stars and the Sun. Despite neutron stars being even smaller than the Sun, their density is folds upon folds greater than the Sun's. Furthermore, radiation pressure is also a factor that limits the size of an object. Extremely large stars exert a powerful outward pressure due to the intense energy production inside them, and this pressure prevents the star from growing any further. Therefore, the maximum size of stars is always limited. Lastly, dark matter and dark energy also play a highly critical role in this matter, because dark matter holds galaxies and galaxy clusters together. Dark energy, on the other hand, accelerates the expansion of the universe. This balance between these two forces is the finest example that explains to us how the largest structures in the universe are formed. While we are no different from a grain of sand in the universe, we interpret ourselves as a very special, very grand, and the most beautiful species. However, when preparing these kinds of videos, especially in this video, seeing how massive the universe is and what fascinating structures it harbors, I understand much better that we truly are just a grain of sand. Yet this does not make us worthless. It's just that because we view ourselves as highly valuable, we live without realizing the other values of the universe. Because of this, we actually become diminished. If humanity stops bickering with one another, focuses on healing its planet, and turns towards science and space, then we would truly become a highly valuable species in the universe. Perhaps the day will come when, as humanity, we will be such an advanced species that we will be at a level capable of managing our entire galaxy. I hope you enjoyed my video. I tried to explain it as detailed yet as simple as possible. If you liked it, don't forget to hit the like button and subscribe to my channel to support me. Also, don't forget to comment both to state your thoughts about this video and to give ideas for future videos. See you in our next video. Take very good care of yourselves. Goodbye.